AMC 10A 2005, problem 20. An equal angular octagon has four sides of length 1 and four sides of length root 2 over 2 arranged so that no consecutive squares, or sides rather, have the same length. What is the area of the octagon? So, first of all, I've drawn the shape right here representing the octagon. And we're told that no two consecutive sides have the same length. So, we can put 1 on here and we can put root 2 over 2 on the other four sides. Now, you can switch the positions of root 2 over 2 and 1, but that won't change the question or our understanding. And now, since this is an irregular octagon with non-equal side lengths, we can divide this into smaller shapes that can be easily found with area formulas. Because since this is not a regular octagon, we cannot apply its area formula to it. So now that we have this, let's try to find the inner shape, because that is the simplest. And another thing to remember is that we must remember that the intersection of each of these lines are at 90-degree angles, because in a octagon that has these conditions will always have lines connecting from each vertex to be intersecting at 90-degree angles. I will not prove this within this video, but for the sake of it, please, if you do not understand it, accept this as true. So each of these intersections is 90 degrees. And what is the inner shape? Since they're 90 degrees, we can say that the length is 1 and the width is 1 from the two respective side lengths. Therefore, the inside must be a square with an area of 1. That was pretty simple. But now, let's tackle the other four triangles, because that would be pretty much of an hassle. So, we know that the exterior angle of any shape will sum to 360 degrees. Since this is an octagon, it'll have 8 exterior angles summing to 360 degrees. Hence, one exterior angle of this octagon will be equal to 45 degrees. Hence, the angle of the interior angle will be 135 degrees. And since this is a equal angular octagon, all of them will have 135 degrees. And now we're trying to find the degree angle of this angle for the triangle, because with that we can apply trigonometric properties to find out the side lengths. And we must subtract 90 degrees from it that's taken by the rectangle, which is 45 degrees, meaning that we have 4 45 45 90 triangles as such. So this will be 45 degrees, this will be 45 degrees, and this will be a right angle. And the hypotenuse will have root 2 over 2. And let's call this side length A, and let's call this side length A as well, because opposite sides to congruent angles will be congruent to one another. So applying our trigonometric property, sine of 45 degrees must be opposite over hypotenuse, which is A over root 2 over 2. Sine 45 degrees is root 2 over 2. Multiply, or let's simplify this. This will be 2A over root 2, which is the same thing as 2 root 2A, which is the same thing as root 2A. And A will be hence equal to root 2 over 2 times 1 over root 2, which is equal to 1/2. So the side lengths of this 45, 45, 90 triangle will have legs of half. And from this, what can we say about the rectangles? Since we have the width and the length of each of these rectangles, we can simply find the area of one and multiply by 4 to find the remaining rectangle areas. That will be equal to 4 times a half times half, which is half, which gives us 2. So the sum of the inner square along with the 4 rectangles will give us a grand total of 3. So now we must sum with the areas of the 4 remaining triangles. And we know the area of the triangle to be equal to base times height divided by 2. Base being half times the height divided by 2 will be 1/4 times half, which is 1/8. Since we have 4 of them, we must multiply 1/8 with 4 to get 3 plus half. Simplify this and you get 7 over 2, finding our answer to be at answer choice A.